My first 5 minutes will be spent on talking about the Data Science Center in Eindhoven. It's the biggest data science initiative in the Netherlands. No university has a center of our size. I will tell a bit about its structure, but the main part of today will be devoted to process mining, and I hope after my talk you will go home and you will put it immediately in practice, because I will show you that it is very easy to do. It's a bit sad to be at a conference like this, but typically people that talk about big data, I think, are often telling blah blah. And you see a tendency also here in the talks that people apologize for talking about that. So big data is a strange word. It's hyped. I'm sure the term will disappear in the next couple of years. But what will stick is the notion of data science. There is a new way in which we are dealing with data that is changing everything. And it's very much comparable to when, let's say, at the end of the 70s, the beginning of the 80s, suddenly there were computers. And we were thinking, what could we do with them? It was not a well-defined area, but it was clear that something was changing. If we look around today and we see what people are doing on social media, with mobile applications, with lights that are connected to the internet, it is clear that something fundamentally is changing and there is a need for a new profession. So that's why we established the Data Science Center in Eindhoven. As I said, it's the largest Dutch initiative in this area. I will just talk about that in 2 or 3 slides. So we have 28 research groups covering the entire spectrum of data science. And I'm not going to read out loud what is on this slide, but if you look at the yellow part, that is related to computing power and collecting data through sensors or other things. Then the red part, in our view the most important part, that is turning this data into actionable analysis results. So here you talk about visualization, you talk about things like data mining, statistics, etc., etc. Then the green part is once you have this, you of course need to influence reality to make it better. And you're also confronting with things like ethics. So we have 28 research groups scattered over these 3 different areas. In total, more than 400 people are involved. And these are the 7 research programs that we have. They are of applied nature, cutting across all these different disciplines. Just to highlight one of the collaborations that we have, last year we started a collaboration with Philips, the so-called Data Science Flagship. And at this point in time, together with Philips, we have 16 PhDs and around that 30 staff members in the area of data science, working on the topics that you see here. So I think it's a wonderful collaboration, showing that for large organizations, data science is something incredibly important. But it is not just research, it is also education. So in Eindhoven, we have at this point in time already 2 master programs in the area of data science. Next year, we will start a data science bachelor together with Tilburg University. We expect hundreds of students to come there and study this new program. And we are creating a data science university, between brackets, in a collaboration with Tilburg University. So there is an old monastery in the middle of 's-Hertogenbosch. I think there were a couple of thousands nuns there before, but I think only 9 were left. So there was this incredible, beautiful property in the middle of the city. And that is where we are going to create a new node. There will be a specific master related to data science and entrepreneurship. And there will be lots of involvement with all kinds of companies. So this is just to show data science. A lot of things are happening also at the university front at this point in time. So let me now talk about the topic that was announced in the beginning. I will talk about process mining as the connection between process science and data science. So it's best to illustrate this using a picture. So what you see here is that here we have data science and all of these disciplines that I just mentioned. On the other hand, there is a whole world that is concerned with making processes better, improving processes, making them more efficient, making them more compliant. And typically people that are working on processes, for example, working on business process management, or any of these types of things, modeling processes, they typically do not look at the data, and the classical people that talk about big data, they never look at processes. They typically look at just one step in a process at best. So process mining is connecting these two worlds. And this is a very fundamental and a very important connection, and it is surprising that so far the big vendors did not pay more attention to this. But I'm sure it will change in the next couple of years. What I'm now going to explain to you is that this is as generic as using a spreadsheet, and it is as easy as using a spreadsheet. And by that, I start talking about spreadsheets. So what's a spreadsheet? I think you're all using Excel here. What is interesting to note for the younger people is that spreadsheets were the killer application making the first generations of computers sell a lot of times. So the Apple II just existed because there was a spreadsheet program for it. The same with the uptake of the IBM PC. So it is very important, very generic. Please be aware that if you use a spreadsheet, the spreadsheet doesn't know what the numbers mean. So it's a very generic tool. It can be about money, it can be about quantities, it can be about anything. The spreadsheet doesn't know, it's generic technology. What does it do? You all know spreadsheets. You can enter data. For example, if I zoom into this part, then we can say, okay, we have a bunch of products. For every product, we have a quantity and we have a price. So these are facts that we enter into a spreadsheet, and then we do computations. Like at 3 times 599 is this number. We can show pie charts, bar charts. We can compute averages, variances, etc., etc. So it's a very generic tool. Everybody in the room is using this. But if I now ask you, how can you use spreadsheets to analyze operational processes, you realize that it is not possible. Because to analyze a process, that is not taking a simple sum over some numbers or computing like an average or a variance. It's something completely different. Just to illustrate this, and I realize it's unreadable, but I will try to indicate a bit what it says. This is a CSV file. You can think of it as a spreadsheet taken from a housing agency, Vestia in this case. Every line in this diagram corresponds to an event, so something that has happened. What do we know of such an event? Well, first of all, we have what is called here a case identifier. We know what is the house that event refers to. So what is the event about? In this case, it's an apartment or a house that has a number. We have the name of an activity. So for example, here you see activities like inspection of the house, registering the future address of the person that is moving, paying a fine because the house was not left in the proper state. You find activities like that, and you have timestamps. There can be other information, like for example, but here I made this file anonymous. So it could be that you know which person executed that activity. I hope that you realize that this type of data is everywhere. If you are looking at SAP, if you're looking at the hospital information system, if you're looking at Twitter data, no matter what data you take, things are happening and they are being recorded. And that is where process mining starts. I've loaded this in a spreadsheet, and what can I do with this data? I can do nothing with this data. The only thing that I can compute is, for example, a pie chart showing me how many times an activity was being executed. In this case, there are 74 different activities. There are 208 cases, 208 houses, generating almost 6,000 events, and as I said, these 47 different activities. Here we see the distribution of these activities. It doesn't tell us anything about this process. It's completely useless. Yeah? So how do we analyze behavior? Well, let's just visualize the event data that I'm referring to. So what you see here, if you look at this slide, then every dot is an event, so there are 6,000 dots here. What you see on this axis is the time, and you cannot read it, but for example, this here says April 2007, May 2007, etc., etc. All these numbers here refer to this case ID, so the house. So if you follow the line, you can see exactly what has happened for a certain apartment. Yeah, that's what we can see. If you look at this data, you note probably two things that look particular. First of all, you see that this line is curved, which is indicating that the inflow of new work, of people moving, is not a constant rate, but it is increasing because it's curved. If you look well, you can also see that there are some suspicious vertical patterns here. If I zoom into this, then you will see that, so for example, if you look at this is this set of dots. So apparently, certain houses have been waiting for weeks for a particular activity to happen, and then on one day, for all of these houses, 2 activities were being executed. In this case, making the final bill and archiving the case. Yeah, so what I'm now doing, try to do it in a spreadsheet, and you will see that this is tricky. But we are viewing this as a process. So we are not satisfied by just showing the data. What we would like to do is we would like to discover models that are describing what people are actually doing. And we would like to have the models that people that are working with processes are used to. Yeah, so not numbers, but process models. So here my youngest daughter, Lucia, she is showing the concept of process discovery. It is finding this path, which is called here a desire line. In Dutch it's called an olifantenpad, showing what people really do. So this is what people really do. This is what their boss says that they do. And there is a significant difference. So process discovery is taking this raw data, as I just showed you, and automatically constructing models. And it sounds impossible, but there are lots of tools and many mature techniques to actually do that. So for example, I'm sorry I expected a huge screen here in this room, but it's just two small screens. What you see here is if you take this Vestia data, this is the process model that is automatically derived based on that data. And I can zoom into a part and you can still not read it, but here are activities like the final payment, the second inspection of the home if the first inspection was not okay, things like that. So you automatically learn the process as it is actually being executed. And so it's showing this, what you would otherwise not see. Of course, the problem of something like this is that reality looks very ugly and very complicated. But you can simplify it and visualize it in any way that you would like. And just illustrating it based on this slide, again, I would like to show everything that I'm showing I can do in 1 second. I get a model, and I do not need to model anything. That's just based on the raw data. So what you see here is this is the process model with all the activities, 74. That is always a complicated model if you see 74 activities on one screen. I can zoom into the 11 most frequent ones. I can even zoom into the 3 most frequent ones. And then you say it always starts with registration of canceling the rent. And after that, there are 2 activities, like register the future address and this first inspection. They are typically always executed, but they are not executed in a fixed order. That's why we have this plus here, meaning that these things can be done in any order or concurrently. And so this is you can read. If you're interested in this process and it's your process, then also looking at these diagrams is very insightful. You also see these numbers, and these numbers, they are real. They are showing you what has really happened in that process, in the period that I selected. Again, no modeling is needed. So I showed you there is this powerful way of creating process models based on raw data that you can find everywhere. What is now the case if you already have a process model that is describing you how things should be done, or how things you think that things go, or what you have discovered? So we have a process model. Here you can see a Chinese process model. It says stay off the grass. And you can see again that reality is showing that there are deviations. It sounds similar to what I explained to you before, but now we have a model and we have reality and we confront them with each other to see where the deviations are. Well, this is very important. There are people that try to design very safe systems, but if you look at the actual data, you can see that there are all kinds of deviations. So that's what we would like to reveal. So again, so that you understand it, before we were completely automatically learning models, we can still use that here, but we can also have a model that people have made, like this is the way that you should handle an insurance claim. Or this is the way that if a person cancels his rent for his apartment, what you should do. And then you check whether reality happens like this. So you take a process model, you take reality, and you confront it with each other. This is again a model based on this data, but I simplified it a bit. So what we can now do is we can check the relationship between this process model, how things should happen, with how things really happen. And if we look at this data set, we find a high level of conformance. 93% of all the activities are executed according to plan. That means that, let's say, approximately 6% of the events are deviating from this process model. So you can quantify the quality of your process. You can also inspect any part of the model and see what kind of deviations take place there. And even if there is just one deviation, you will be able to find it. So in this case, if you look at this activity, the small purple bar here, that was skipped 40 times. So it was supposed to happen, but it did not happen. It was skipped in 40 of these 208 cases. So you can see where the deviations take place. You can also reverse the view. Now I'm looking at the data, and I'm trying to understand where in the data are my problems. And again, everything that is in green is okay. If you look at the things that are in purple, they correspond to something should have happened, but it did not happen. For example, there should have been an inspection, but the inspection did not take place. It could also be, and these are the yellow parts, that indicate something has happened that should not have happened in this part of the process. And we have been applying these types of things in many, many organizations. So for example, so we recently completed a book on applying process mining in hospitals. And then it's very interesting to see what doctors actually do. And for example, what is the relationship now between deviations of the medical protocol versus incidents that take place in the hospital. And in the data, it's all there to research these types of questions. But it's not only that, it can be applied to any domain. It's as generic as a spreadsheet. So it's not just about conformance. We can replay reality on top of these models. We can confront them. And then we can also highlight where there are bottlenecks. Because in all data sets there are timestamps. So it's completely trivial now to show how much time is spent in all the different parts of the process. So if I zoom, for example, in these things that are in red, these are the bottlenecks. I can see that this activity, I cannot read it. I think it's waiting for the first inspection, that there is typically a waiting time of 15 days before that activity. Yeah? Again, I do this without modeling. Just learn the model, replay it, and I can see the bottlenecks. Very, very simple. We can also animate real-life behavior on top of such models. And now I'm going to do something very risky. I'm going to show you simply the software, so that you have an idea how easy it is. And I take the log that I just mentioned, cannot read it myself. And so now I've loaded this log that I was using all the time. So you can see there are 208 cases, 600 different events. And now I can, for example, show you this dotted chart that I mentioned before. And now I need to change some things. So I can change the different views. Let me try to... so for example, here I'm now showing you all the different activities, and you can see exactly when which activity took place. I could also visualize it like this: when did people work on something? So I can show any visualization of the data. I can also color the attribute, for example, based on the activity that was being executed, and now you see these horizontal bars. So I can visualize the data in any way, but just that you can see this is the same type of data as what I showed before. And now I can learn a model. And what you will first see is a model that you cannot read. This is a model with 74 different activities. So I can zoom in and you can see that there is a particular activity mentioned. However, I can zoom out and I can make the model simpler and simpler. And because this beamer is really bad, I need to go down quite a bit. So let me just go to, I don't know, this level. What you now see is that you can, let me zoom in, that you can really see things. So what you now see is you see the activities, you see how different houses are flowing through this process model. Different cases are being handled. I can also show, for example, the queue length. And if I now, for example, zoom into this part, I'm not sure. So now you can see, for example, there are 20 cases queuing in front of this thing. And again, just so that you're sure, I just used a CSV file, the file that I showed at the beginning. So this is to show that it really works. So to conclude, I would like to summarize a few things. So first of all, process mining allows you to see what is really happening. So the blue line here is what people say that is happening. The red line is indicating what is happening, and you can see where the deviations are. We can squeeze reality in such models, and we can automatically see costs, waiting times, flow times, all of these types of statistics. I hope that everybody is enthusiastic. You would like to start using this today. So what do you need? It's very simple. You need event data, a process mining tool, and a data science mindset. So the event data, it is something like this. We have been applying this, I don't know, in 30 municipalities, 20 different hospitals, but also in companies like Philips, where we monitor the usage of certain devices, like X-ray machines. The spectrum is very broad, but we always find this data where we have a case ID, what is it about, in this case a patient, an activity name, a timestamp, and there may be all kinds of other data that we can use. But this data is everywhere. If you have SAP, your system is loaded with this type of data. So it's in databases, event logs, transaction logs, message logs, Twitter data. This data is everywhere. Process mining tools. All the slides that I showed, and also the demo that I just showed, was made using PROM. So PROM is an open source tool. It's for free. You can download it today if you want. And it is an incredible, powerful, and very, let's say, versatile tool. It is offering, let's say, up to 1,000 different types of analysis that you can do. Because of that, it can be confusing, let's say, for people that start in this area, because it has all these different functionalities. Therefore, it's also very important to mention that there are also many commercial tools available today. Here you see some names of tools. So all of these tools are based on the ideas that we have developed in Eindhoven over the last 15 years, and they are now being productized in many different tools. So for example, If you look at Disco, that is a tool that is from a company that was created by two of my former PhD students. That you can see how these things work. If you look at, for example, Celonis, if you're buying SAP, Celonis is on the price list of SAP. So you can also use that in a more customized way. You need to have a data science mindset. And if you're interested in this material, you need to open up your mind for a different way of thinking. Not starting with pen and paper and making process models how you think that things go. No, just look at the evidence. If you're interested in that, there is this massive open online course on process mining. It is starting next week. So if you're interested in this topic, it's a free course, and it has already been taken by up to 70,000 people. So you can see there's a big interest in this topic. To conclude, I hope I told you something about the Data Science Center Eindhoven. Many things are happening, 28 chairs, and I've been talking about one of these 28 chairs that is focusing on process mining. Process mining is the bridge between people talking about processes and people talking about data science or big data. It's the missing link that is incredibly important. Process mining can be used to answer performance-oriented questions and conformance-oriented questions. Are we doing what we are supposed to do? Are there any deviations? Where are the bottlenecks? Why are they there? There's a very generic way of analyzing these types of things. And you can start today, as I tried to highlight in the last part. Thank you very much.